All right, guys, I'm going to continue on, and now we're going to talk about inequalities. So a couple things with inequalities. The basic idea of solving them is going to be the same. The setup, however, it's really important that we set them up a specific way. When you set up the equations, doesn't matter which side of the equation you put the numbers on. In inequality, it does matter. So more specifically, when you have problems like numbers 5 and 6. So on numbers 5 and 6, you have the log on one side of the inequality. So anytime you do this problem, just like in an equation, you would have to set it up so that it's in exponential form. Now, this is what you have to watch out for. The value. Okay, so this is what we call the value, x right here. That has to be on the left-hand side when you're setting up the inequality. So the value must be on the left. Okay. So if I wanted to set this up, I start with the value. And then I use my greater than or equal to sign. And now I do the base raised to the exponent. So a little bit different than we did yesterday. Okay. Now you would solve this. So you just take 4 and cube it. X is greater than or equal to 64. Now the other thing that you have to pay attention to is, just like when we were solving the equations, we had to check to make sure that our answer was okay. I have to do the same thing here. So I know that the value, so this value here of x, has to be greater than 0. Because that's what it says up here anytime you have a logarithm. The value has to be greater than 0. So this is why we use a sign analysis. Okay. So my critical points would be the 0 and the 64. Okay. X has to be positive, greater than 0, so I have an open circle. X also has to be greater than or equal to 64. So I have a closed circle. Now here is the nice thing. You don't actually have to plug values in. Instead, I'm just using the number line that goes along with the sign analysis just to make sure I have the correct answer. So the value of x has to be greater than 0. So I can cross that section out right there. That's where I start. Start with the value being greater than 0, or if you have to solve whatever it is, being greater than the number you solve for. And I'll show you that when we get to number 7 and 8. So I start there. Once I do this part of it using this first critical point, now I go to the inequality that I actually solve for. So my solution was x greater than or equal to 64. That solution is always going to be your solution as long as you didn't have to worry about the other part where the value was. Okay? So since x is greater than or equal to 64, which is greater than 0, so I don't have to worry about that, this actually becomes my solution. So the answer is the interval from 64 to positive infinity. Okay? Now, let's go on to number 6. I'll show you again. So we have the log on one side, so I know I have to set it up in exponential form. I always take the value and put it on the left. So the x goes on the left. I use the less than sign. And now the base raised to the exponent. So when I solve that, I get x less than 16. Okay. Now, I have to double check using the definition of a logarithm. So I know also that x has to be greater than 0. So I'm going to put this on the number line. I'm not analyzing the signs. I'm just using this to make sure I get the correct answer. Okay, so x has to be greater than 0, which means to the left of 0 is crossed out, cannot be part of my solution. Now I go to the solution that I got when I solved. So x is less than 16. So I know that x is less than 16. However, it has to be greater than 0. So my final answer, I just use that number line. So my answer is the interval from 0 to 16. Okay. Now for numbers 7 and 8. Remember, these are the ones that were a little bit easier to solve because you have the log on both sides. So you're just using the two values. So when I use these two values, I have, excuse me, x plus 3 greater than 2x plus 1. Solve that inequality. So subtract 2x, subtract 3. Solve this, I get x is less than 2. So that was the solution to the logarithmic inequality. Now I have to check the values. So I know that this value of x plus 3 has to be positive, so it has to be greater than 0. That tells me that x must be greater than negative 3. I also check the other value. So 2x plus 1 must be greater than 0. So x must be greater than negative 1/2. Okay, I have my 3 critical points that I'm going to put on the number line. So we have the negative 3, negative 1/2, and positive 2. Over here, these must be true. So x has to be greater than negative 3. Cross those out. X has to be greater than negative 1/2. Cross those out. X is less than 2. So it's less than 2, but it had to be greater than those other two values. So my solution is the interval from negative 1/2 to positive 2. Okay. All right, you want to pause it, try number 8, and then after that, pick it up and make sure that you get the correct answer. So I'm setting it up and solving the inequality first. Okay. Go ahead and find these values. So I know that 2x plus 5 has to be greater than 0. So x has to be greater than negative 5/2. 4x minus 3 has to be greater than 0, so x has to be greater than 3/4. Okay. Open circles, x less than or equal to 4, closed circle. Greater than negative 5/2, greater than 3/4. Less than or equal to 4. So hopefully your solution is the interval from 3/4 to 4. Okay. And your homework, excuse me while I just double check, is going to be numbers 11 to 15 on the following worksheet.